So look at these questions. Substance Q is a hydrocarbon. So when they say hydrocarbon, we have to put it in this general form, CXHY. When 1.00 gram of Q is completely burned, 3.22 gram of carbon dioxide is produced. What could be the identity of Q? So let's think of the complete combustion equations for hydrocarbons. The general equation is like this. So let's take a look here. I write down here CXHY plus X plus Y over 4 O2 XCO2 plus Y over 2 H2O. So this is the general equations for the complete combustions of H2O. And let's put the information here, 3.22 gram of carbon dioxide. We put it right below of carbon dioxide, 3.22 gram. So let's say I name it as M, and below of it I put N, which is the mole. I'm going to convert it to the number of mole, 3.22 gram divided by molar mass, 44. So the number of mole is hence 0.0732. So this is the number of mole for carbon dioxide. Okay, number of mole for carbon dioxide. Let's look at the hydrocarbon here. As you can see, they give you the mass as well. So we have a mass of 1.00 gram, and to change it to mole, we do the same thing like carbon dioxide. We take the mass in gram and divide by the molar mass. So when you look at the formula here, we have X carbon, and we know that the relative atomic mass of carbon is 12, and the relative atomic mass of hydrogen is 1. So we can find out the molar mass by doing 12 times X, this is for carbon, and 1 times Y, this is for hydrogens. So we can't do much for this as we have unknown here. So we just remain it as 1 over 12x plus y. So to continue doing this, we focus on the ratio. So you can see the ratio of the equation here. We have 1 for hydrocarbon, we have X for carbon dioxide. So let me write down at the bottom here. So hydrocarbon ratio to carbon dioxide, it is 1 ratio to X. So at the meantime, I will bring down the mole ratio that I obtained here. For hydrocarbon, I have 1 over 12x plus y. For carbon dioxide, I have 0.0732. So I put them in ratio, 0.0732. So what am I trying to do here is I want to find out the ratio of X and Y. So what can I do here is I multiply the ratio here with 12x plus y to get rid of fractions. So by doing so, I have 1 ratio to 0.0732, 12x plus y. Then I can multiply inside the decimal. So I get 1 ratio to 0.878x plus 0.0732y. Now we can compare between this one and this one. So we can equate them. Okay, by equating this, we get x equal to 0.878x plus 0.0732y, and we keep doing this. So let's say now what am I going to do is I bring over the 0.878x to the left. So I minus, then I will get 0.122x equal to 0.0732y. So x over y is hence equal to 0.6, which is 3 over 5. So we get x ratio to y equal to 3 ratio to 5. So the ratio here is important actually. The reason is because, as you can see here, when you know the ratio of x, y, which is 3 to 5, then we know that our hydrocarbon will take that ratio also, which is C X H Y. So the x and the y here will take the ratio of 3 to 5. Now let's look at our choice here. The first one is cyclohexene. Cyclohexene. So I read it here. Cyclohexene is actually a hexagonal structure with a double bond, and if you count the number of carbon and hydrogen, you should get C6 and H10. And you can easily see that the number of carbon is 6 and the number of hydrogen is 10. So carbon to hydrogen ratio is 6 to 10. If you simplify that, this is 3 to 5. So hence it matches with the ratio that we found. So the answer is A. So for extra information, let's look at B, C, and D also to check whether the ratio is 3:5 or not. So let's take a look for B. Cyclopentane is actually a pentagonal structure. Molecular formula C5H10. As you can see, the ratio here is 5 to 10. It is not the ratio of 3 to 5. So hence this is not acceptable. And let's look at C. For C, ethene. Ethene is actually C2H4. So the ratio is 2 to 4. 2 to 4. If you simplify it, this is 1 to 2. Again, it doesn't match with the ratio of 3 to 5, and hence this is not accepted. For D, pentane is actually C5H12. So the ratio is 5 to 12, and this is not the ratio that we count. So hence this is not accepted. So the answer is A.